Today we are going to discuss that programming part, which we have seen the theoretical way yesterday, and also we solved it mathematically. So we'll try to do the same using the machine learning, like the Python programming. Okay, and everyone is fine with the timing 7 to 8.
Yeah, okay.
Going forward, like from tomorrow, also can we have it 7 to 8?
Yeah, okay.
Okay, thanks. Okay, my screen is also visible. So okay, let us go through the code. So first you could see, first of all, I've imported whatever the libraries I've needed it. Okay. So first I've imported import numpy as np. Numpy, as I mentioned, is a numerical Python, which is a library in machine learning. So instead of writing everywhere numpy, 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 I just given an alias name. So instead of this numpy, I just use np wherever I need it. So in the theoretical code also yesterday, I've used np.array, means I've created an arraysm. So if it is a very big name, instead of that very big name using it, I'll just creating a short form. That's all. Next, for pandas, I've just used pd. Okay. Next, if you guys could see, import matplotlib.pyplot as plt. Under that matplotlib class, I'm importing a function called pyplot. For that, I'm just giving an alias name as plt. So wherever I want to use matplotlib.pyplot, I'll use plt. And then from sklearn pre-processing, import standard scalar. Okay, I am yet to discuss about this standard scalar. I'll discuss in short while. Is standard scalar is discussed already? If I'm not sure.
No,
Standard
sir.
scalar and
No,
min-max scalar. Okay,
no,
okay,
no.
fine. Okay, okay. I'll discuss post this. I'll complete this algorithm. Okay. So we already know how to read a CSV file. So I already have advertising.csv file. I'm just reading it. And these are the columns of, this is the file content. I have more rows in that. I think I have some 150 or something. I'm not sure about it. So if you guys could see df.8, I have given 4. So that's why it is giving me the first 4 rows. So what are the column it consists of? It consists of TV, radio, newspaper, sales. In this, TV, radio, newspaper are my independent variables, and sales is my dependent variable. So we are basically uh, basic we are basically going to build a machine learning model between TV versus sales. So given this the TV price, what might be the number of sales? Okay, so this is a very basic data set. If you try to understand this thing very clearly, you can basically change whatever the data set you have it, and you can implement it. So let us take TV versus sales. So first I'm doing the df dot drop na. So what this will do, this will drop all the nan values if there are any rows. Okay, post to that, if you guys see, in x I'm taking TV values. So what this will do, this will take this all values 230, 44.5, 17.2, 151.5, and so on, so many values will be there. All the values will be stored in x, and y is I am taking sales values. So all 22.1, 10.4, 9.3, 18.5 will be taken in the y, and there will be so many sales values also that will be taken. Okay, so if you guys see here, scalar is equal to standard scalar. So this standard scalar I'm taking from here. This is a class. Standard scalar is a class. Under that standard scalar, okay, I'll explain the min max scalar, standard scalar. Maybe it might be difficult. Okay, there are two scaling techniques which are available in Python. One is standard scalar. The other is a min max scalar. So before we feed our data to the machine learning model, we generally scale the data. So why do we scale it? I'll explain it. Why we scale it. 1 minute, just a minute. So we have a predefined formula for this. For standard scalar, the formula is something like this: z is equal to x minus mu by sigma. For min-max scalar, the formula is z is equal to x minus x min divided by x max minus x min. Okay, first let us understand the standard scalar. So I have the TV values. In my TV values, I have the value something like this: 22.1, 176, the 188, 192, something. The values are something like this. Agree?
Yeah.
Okay. So if you just look at this formula, we have three things. This x, this is the basically this x. So x is here. This, what is this mu and what is the sigma? Mu is basically the mean, and sigma is basically called a standard deviation. We already know what is mean, what is standard deviation. So for this entire column, I will calculate the mean. So it is coming around 190.5 is the mu. This is 120 you can consider, and sigma is basically some 17.5. So you know the formula for calculating the standard deviation also. Post that, what you have to do, you have to pick each value from here. Say 122.1 minus, the formula is mu, right? So mu is 190.5 divided by sigma is 17.5. So if you compute it, you will get in a you will get in the range. I'm not sure about the range. Generally the range from -3 to +3. It will not be beyond that. So these value will be reduced, means normalize. Just a minute, I'm getting a call. Okay, sorry, I will continue. So what this will basically do, this will basically replace the value 122 with something very small value, something like this 1.0. So if you guys do the calculate, open the calculator, and if you guys do it, you'll get something value, you might get in the minus also, minus 0.16 also. So the value might be ranging from -3 to +3, very closely. So we know when the numbers are very big, the computation, the doing the computation is very very difficult, right? Even for humans. So that's why we are basically reducing the a very big number to a small number. So this is related to standard scalar. What is a min max scalar? So min max scalar, what it will do, we know we already have this x here. It, in this entire values, it will find out what is the smallest value. The smallest value here in our case is 122.1. The largest value is 192. So it will take the value 122.1 minus 122.1 divided by 192 minus 121. So it's already 0. So 0 by something is also 0. So the answer is going to be 0 for the first value. And for this value, it is going to be 1. For the other remaining values, so the maximum range of this min-max calendar is 0 to 1. So anything, whatever it is, 1 lakh, 10 lakh, 1 crore, or billion, million, whatever the number is, if we apply the min-max scalar, your value will be ranging from 0 to 1. That is the role of min-max scalar. But in standard scalar, we are not sure about the range, but more shortly, it will be falling in the range from -3 to +3. Okay. Okay. So you will all have a question in your mind. What is the use of the standard scalar and min max scalar? So why do we do this? I'm sorry, 1 minute. Okay, so see, for example guys, let us take one real example. Say you're going to predict the price of the house. Okay, giving the square feet, the age of the house. Age of the house means when it was built. Maybe it was built 15 years back, or 10 years back, or 25 years back. So if it is built long ago, the status of the house means the conditions of the house also will be normal. If it is built recently, it will be in a good in condition, right? So the uniqueness of that age of that house can be ranging from 1 to 100. It cannot be beyond that. For even for humans, the age cannot be more than 100. Very few people will live till 100, 101, so we'll keep maximum value is 100. Beyond that, it cannot be anything. If you guys go for the square feet, the square feet cannot be 1, 2, 3 or something. It may start from 250, 300, and it can go to any value, a very big value also. So that is the uniqueness of that feature. So that ranging, because that feature can hold very big number, but age cannot go beyond 100. So when I'm giving this data to my machine learning model, my machine learning model will think I should give more importance to square feet, not to age of the house, because the numbers are very big. Okay, so it will see, as I already mentioned, machine learning does not have any intelligence. It is only good at computation. So if you directly feed the data to the machine learning model, it will come up with some assumptions that I should give more importance to square feet, not to the age of the house. Age of the house is also matters a lot. So in order to avoid the confusion, we are basically taking the approach of standard scalar and min-max scalar. So before we feed the data to the machine learning model, we basically normalize it. So these two concepts are comes under the topic on normalization. So you're basically normalizing. You're basically reducing a very big number to a very small number. So when you go with the min-max scalar, all the values will be ranging from 0 to 1. If you go with the standard scalar, more shortly it will be in the ranging from -3 to +3. Make sense? Understood?
Except
Thank you. So now if you guys see, so the formulas, whatever we have seen, nothing you're going to write, it's all already available. So standard scalar. So I told the standard scalar is a class. So when you want to access the class, you should create the object, right? So scalar is my class. Sorry, scalar is my object. So if I want to use the functions which are defined under this class, I should invoke via the object. So scalar dot fit transform. So fit transform is a function which is basically used to do the that this calculation. So whichever we did here, right, this calculation and this calculation. So there are the function name is fit transform. So the role of fit is to find this mean and standard deviation in standard scalar, and in min max scalar is the role of fit is used to find the min and max value. Transform is to apply this formula. Okay, so if you guys just pass x, this x is basically the tv values, right? So if I just pass my x values, if you guys see the x scaled values, now previously it was 230, 44, 17, 151, but now if you guys see 0.96 minus 1.9 minus 1.51, 0.05, so some values, so those values are normalized. So what I'm also checking x scaled dot shape of 0. As I mentioned yesterday, shape will return me rows and columns. Now if you guys see here, the rows, the number of rows and columns in the x is 200 rows are there and one column. This is fully one column, right? In that rows and columns, I'm going to pick the rows. So I'm telling shape of 0. So what will be the answer, guys? What will be this answer? This line answer. If I print, what I'll get?
one.
How come 1? You guys do the indexing. 0 is 200, 1 is 1. See, it is
So
returning me no 2. How come 2? 2 only we don't have, right? See, r comma 0 1 column. I have 200 rows and one column. I am telling shape of 0. This is 0 and this is 1. So what will be the answer of this one?
200.
Very good. So answer will be 200. So if you guys see below, 200 is the answer. Now I have to add the bias and the slope, right? So the formula we know, y is equal to mx plus c. This m and c are called my parameters of the model. So if you closely look at here, x scaled is equal to np dot c underscore. So we'll break this function step by step and we'll try to understand. So first we'll give importance whatever it is in the bracket. So if you guys, if the one which I've highlighted, we already know this x scaled is the previous answer, which is this one, 0.6 minus 0.8, 0.51. So all these answers are x scaled. So now I'll concentrate on this part. And also we already computed this value, x scaled dot shape of 0 is 200. We already know. So for that they're applying np dot ones of 200. So what this will do, this will create a list with 200 ones. Yesterday we saw a function called np dot zeros, right? If you say np dot zeros 100 means it will create a list with 100 zeros. It is ones means it will create 200 ones. Got it? So this entire is going to give me a list with 200 ones. So if you guys see, I have explained very clearly everything. X scale dot shape of 0 is the number of rows in the data set is 200. NP dot once x scale of shape of 0 is, so if it is 2, it will create this many number of ones. After this, outside if you guys see, np dot c underscore means concatenation. C means concatenation. C underscore, you should use that C underscore also. That is a syntax. So this will merge this answer and this answer. So if you guys see, so to this above output, it is just adding 1, 1, 1, 1 to every value. It's basically something like this. Yesterday we had, right, 1 comma 1.2, 1 comma 2.3. I told I'll explain about this later point of class. So this is what, that is where I'm adding this one. This is one dot means it's just a float number. We have different types of data types, so integer, float. So 1.0 it's basically. Understood?
Yeah.
So if you guys really understood the theoretical part yesterday, understanding this will not be very difficult. For all the 200 values, I'm just adding 1 comma 1 comma 1. Next, if you guys see x scaled dot shape of 1. Now if you guys check the shape of this x, what is the shape of x now? X scaled. How many rows and how many columns are there? If you want, I can explain the rows. Rows I can tell you 200. See, previously it was 200 comma 1. Now it is, rows is going to remain the same. Columns is going to be, see, previously I had only one column. Correct? I had only one column. Now how many columns you guys have?
2 columns.
2 columns. So it's going to be 2. So in the code, if you guys closely look at it, I'm taking x scale dot shape of 1. Out of this index, I'm going to take this is 0, this is 1. So what is the answer? It is going to, I'm going to get it
2.
2. Very good. So it's going to be 2. So that's why you're getting the answer as 2 here. And np dot zeros x scale dot shape of 1. So it's going to create a list with the 2 zeros. Yesterday we saw in the theoretical, same thing. So the first 0 is for the intercept and the second 0 is for the bias. Sorry, for the slope. Okay, I'll come to this function later. So now I'll also come to this function later. Now to go to the main function. Alpha, yesterday we have discussed alpha at 0.01 iteration. So yesterday I told I'm going to run it for some number, for loop, some number of iterations to find out the best slope and best intercept. So I'm going to run it for 1000 times as of now. So I've defined my function called gradient descent. I'm going to pass my input.
Your voice is not audible.
Your voice is not audible, sir.
This is not audible. I'm 723. Guys, is it audible now or not?
Yes,
Yeah,
yes, now
now
audible.
So, okay, I think you guys lost where here you guys understood the range. Tell me, guys,
from starting with the depth gradient.
from where?
Depth gradient is it?
Okay, okay, I'll explain. Okay, so this is the gradient descent. We have passed parameters like input x, input y, theta, alpha, and iterations. So this m is equal to n of y. We calculated to know the number of rows. Cost history is equal to np dot zero iterations. We know we have 1000 iterations. So 1000 zeros, it will create a list with 1000 zeros. So I'm going to iterate this for 1000 times, right? So this iterations is the value is 1000. So it ranges from 0 to 999. So first my I value is going to be 0. I'm going to do the step 1, which you have seen a theoretical one, x dot theta. Step 2, predictions minus y. Step 3, step 4. So all these 4 steps which you have seen yesterday. Post that, I have to calculate the MSC, which is mean squared error, to know how much my model is deviating, right? So I'll invoke the compute cost. Audible?
Yeah.
So x comma y dot theta. So we know this is the formula for calculating the MSC, right? Yesterday we have seen 1 over m summation of I is equal to 1 to the power n uh, y minus y cap the whole square. So this is the formula. This y cap can be written as mx plus I, sorry, mx plus c. So this is what they have written in the programmatic way. So the summation I'm doing it right. This sum they have written as np dot sum. I'm doing square here. That's why np dot square. Predictions is this predictions. And why? So return cost. So this will be returning the cost for the step one. It might be some 192 dot something. So over a period of time, the cost will be increasing. So finally, this is your best slope and best intercept, and this is the final cost after 1,000 iterations. So if you guys see here now, the graph after 200th iteration, the graph has become steep. Means even if you guys iterate after 200th iteration, the graph is steep, so the slope and the intercept will not change anymore, as I mentioned yesterday. So in the initial stage we have taken m is equal to 0, c is equal to 0. My cost is very high. Over a period of time it is gradually going down, gradually going down, and it is converged at the iteration is equal to 200. Understood?
Yes, sir.
Okay, so whatever I discussed now, theoretically the same thing can be done with one line of code. So whatever I explained now, so you guys can basically do it in a one line of code. So this model is equal to linear regression. If you just write this line and fit and predict, that's all. These three lines of code will only take care whatever I explained here. This gradient descent, compute cost, all will be taken care by these three lines of code. So this linear regression is a class. You have to import that class using this line. From Scikit-Learn.linear model, import linear regression. Okay. Any doubts, guys?
No, sir.
Okay, so I'll share these documents. Please kindly go through. See, at the first stage, it is difficult to understand. Try to execute in your own mission. Try to analyze. See, I'm not asking you guys to mug up or memorize the code or something. Try to execute the program. Try to understand each and every word in this program, whatever it is written here, why this is written. If you're not able to understand, do print and try to get that output, and you will slowly understand it. Okay,
Okay, sir.
I'll share the things. So going further, we'll have the class at 7 to 8. Is that okay with all?
Yeah, for me, it's okay.
Sorry, Gangotri?
Yeah, it's okay, sir.
Yeah, okay. Okay, guys, you can ping me if you guys have any doubts in execution part, or if you could not see, if you understood linear regression very clearly. This is I could say this is a basement you're putting it for the machine learning. Once this is very clear, you can basically gradually learn the other algorithms very easily. Though there are differences between the other algorithms, but these basically the basement for the entire building. Layashri, able to understand?
Yes, sir.
Okay. Saurabh, Gagan Reddy, Shivashankar, Kirtana, Kengapriya, Ranjita, Kaushalya, all able to understand?
Yes, sir.
Okay. Others? Okay, I'll share the materials. Kindly go through. If you guys have any doubts, please reach out to me. Okay, Gagan. Thanks. Thank you, guys. Bye bye. You guys can drop.